This question's about resistance. It says a student investigates the resistance of a lamp. The student uses a circuit that contains an ammeter, a battery, a lamp, and a voltmeter to determine the resistance of a lamp. Now we need to remember that resistance is equal to the potential difference, or the voltage, divided by the current. So we're going to use the voltmeter to measure the voltage, and we're going to use the ammeter to measure the current, and then that's going to allow us to work out the resistance. So let's draw the circuit diagram. So the first thing I put in is the battery, and then I put in the lamp. And then I'd have to think, which way around do I connect up the ammeter and the voltmeter? Now the ammeter measures the current flowing through the lamp. So it's got to be in a series circuit with the lamp. It's measuring the current flowing through the lamp, because series circuits, the current is the same the whole way around the circuit. The voltmeter measures the potential difference, or the voltage across the lamp. So we're going to connect our voltmeter in parallel with the lamp. Then it asks us to state the relationship between voltage, current and resistance. We've already talked about this here. I always remember it as V equals I times R. Voltage equals current times resistance. Then it says the student obtains this graph for a filament lamp. Now, some of you seen this sort of question before might sort of think, well, hang on, we wouldn't be able to obtain this with this equipment. They would have had to put in a variable resistor here. However, they didn't state that in the question, and that's the reason you don't actually need it in this case. But usually, don't forget that variable resistor, because otherwise you'd just be able to take 1 point on this graph, which in this case wouldn't be very helpful, because we can see that the resistance is not constant. It asks you to calculate the resistance for the lamp when the voltage is 6 volts. So we need to work out what the current is at that point. So we draw up from 6 volts and then draw across, and we get 1.5 amps. So resistance equals voltage divided by current. We've got 6 volts divided by 1.5 amps. And so that's going to give us a resistance of 4 ohms. Then it says the student reverses the battery connections. So he takes this battery and switches it the other way round. So it's sort of like that. On the axis below, sketch the graph that he would obtain. Part of the graph has been done for you. So here we've got what we would call the forward bias, where we've got the current flowing forwards and then what the voltage would be. Now if we let the current flow in reverse, it's going to sort of mirror this image, but we've got to be quite careful that we keep a few things the same. Now notice that the maximum current is just 1 square, so we don't want to take it and change any other point. And then we've got to make sure that it's approximately the same. So if I draw something like this, that's going to make the examiner very happy. Then it says the student replaces the filament lamp with a light emitting diode, or an LED. He notices that there is no current in the diode when the battery is reversed. He replaces the battery with an AC supply, or an alternating current supply. Which graph shows how the current in the diode varies with time? Now, if we just looked at the current in the circuits, we would see this. We would see the current is alternating between negative and positive, negative and positive, negative and positive. But because there's a diode in the circuit, it only lets the current flow in the positive direction. And so, when the current's trying to flow in the negative direction or backwards, it doesn't flow. It's only when the current is trying to flow in the positive direction that it flows. So that is what you would see in the current flowing through the diode. You'd sort of see half the alternating current only when the current is positive.